we're going to talk about classifying quadrilaterals. And again, it's a nested Venn diagram where the outermost oval, in this case, is going to be as generic as we're going to get, and then as you go to the inner circles, it gets more and more specific. So the first one is that we're going to look at quadrilaterals. So quadrilaterals are polygons with 4 sides and 4 angles that add up to 360 degrees. Anything with 4 sides and 4 angles. So up here, outside of these other ovals, we have this one, which kind of looks almost like a trapezoid, but not quite. And we have this one that kind of looks like the Star Trek symbol thing. But we can have quadrilaterals that aren't more specific than quadrilaterals. We could say that this one is an irregular quadrilateral and that one's a concave irregular quadrilateral, but it just doesn't have a specific category that it would fall into. Then we have over here the trapezoids. We'll go to the trapezoids next. Do I have pluralized? I think I pluralized. So the thing that all trapezoids, well actually you can think. Go ahead and look at the examples inside the oval there. What do all trapezoids have in common? All the examples, some of them might turn your head sideways, some turn your head this way. What do all trapezoids have in common?
They all have 4 sides.
That would be quadrilaterals. Hold on, let me give her a little hint. Look here and here. Look here and here. Look here and here. Look here and here.
They're along their sides and like they're 2.
What's that word? Train tracks.
Parallel.
Parallel. Has 1 pair of parallel sides. And if you're like me and you get things confused, especially when they start with the same letter, the way you remember parallel as opposed to perpendicular, which I say perpendicular to remind me, but parallel has these 2 L's that are parallel to each other inside the word. Parallel. And then it has a little last L too. I mean, whoa, it's just so much parallelishness going on in there. Okay, so it has 1 pair of parallel sides. Now, you know I stink with memory, so here's my trick to remember trapezoid. How many of you here have ever seen like any of the Star Wars movies? I don't remember which one it was. So there was a Star Wars movie where 2 of the characters, they got trapped in like a garbage pit, like a trash compactor thing, a giant trash compactor. Shh, that's not still appropriate. Okay, so if you picture it, it's got a floor and it's got a ceiling, but the walls started trapping them in and squishing them in. So the trapezoid, I think it's got a floor and it's got a ceiling, but the walls start caving in on you and trapping you in. So trapezoid, you're trapped in there. The walls are. I need tricks, okay? All right. So and also, Mrs. Kimball, Mrs. Angus's room has trapezoid tables, and I actually have 2 on the side. But those are isosceles trapezoids.
Yeah.
So a lot of times people only think of those type of trapezoids when they think about trapezoids. But anything where you have a floor and ceiling, and the wall, at least one or both of the walls are like, you know, angling in at you. Trapezoid. Now, this next big oval over here has lots of different examples inside. It's got this. Does anyone know what all of these could be called? Yes, sir, in the back. Parallelogram. So these are all parallelograms. Anyone want to take a guess at what they all have in common? All parallelograms have what? 2 pairs of parallel sides. Now also, notice those little notch marks? All of the opposite sides not only are they parallel, but they're also going to be congruent, because things have to end up matching up to be closed. So, I forget how I worded it. Oh, opposite sides are parallel and congruent. So if you have a parallelogram, then if you know one measurement, you know the one across from it too. Yes, sir.
Well, also, aren't the angles opposite?
And so therefore the angles that are opposite each other, but opposite angles is a little more confusing, like diagonally across from each other, are going to end up being parallel.
Not adjacent.
Not be adjacent.
You know,
All right, now we have some more specific types of parallelograms. We have all of these ones. See these four right here that I'm pointing at here? In this upper circle inside? What might I call all of these? Except for these two. My kids can get that and they're only like 4.5 and not even 2. But these ones, not so much. They get confused with those because most people do. What are these?
a rectangle.
These are all rectangles. Even these ones are rectangles. All of these are rectangles.
Oh, that's square. Rectangle.
So, who thinks they can explain what all rectangles have in common? We already know that they have 4 sides and 4 angles that add up to 360 degrees because they're inside that outer part of the Venn diagram. We already know that they have opposite sides that are parallel congruent. So what else do rectangles have more specifically? Yep.
They have 4 corners and perpendicular.
The corners are perpendicular, but perpendicular means right angles. Yep. So they have 4 right angles. So rectangle, somewhere, I don't know if it's Latin maybe, but rect means right in some sort of prefix world. So rect, right, right angles, rectangles, right angles, rectangles, right angles, so yeah, it's pretty much telling you what it is. But the thing that confuses people are these ones, because these are rectangles, they're just a very specific type of rectangle. But we're going to look at the lower circle down here before we look at where they overlap. What do these shapes down there, where they're parallelograms that have all 4 sides congruent, if you notice the notch marks, what are those called? Yes, ma'am?
Rhombus or rhombi.
Those are rhombuses or rhombi. Now my kid, the one that's not even 2, he plays a game where he has to like pick the shape, and it always calls it a diamond. So mommy's in the background going, it's a rhombus, it's a rhombus, it's a rhombus. Find a rhombus, because why not use the word rhombus right from the beginning is my thought, but whatever. Hexagon he's supposed to know, but rhombus, too difficult. I don't know. It's too good. All right. So rhombuses, or the plural would be rhombi. They have 4 congruent sides, in addition to having all that other stuff that a good parallelogram has. And for whatever reason, to remember even that word, I think that on Dancing with the Stars there's a dance called rumba, the rumba. So then, for whatever reason, I go, oh, it's the one that sounds like the dance. Oh, rhombus. So that's how I remember it. It has nothing to do with actually what it looks like.
I don't watch TV.
Maybe because they're stars, like diamonds. We'll make up our own little memory trick. All right. Now here's where the confusion usually falls. If I have a rectangle that also is a rhombus, so I have a 4-sided figure with 4 angles that add up to 360 degrees where opposite sides are parallel and congruent, there are 4 right angles, and those 4 sides are all congruent. What do I have? So this is a very, very specific type of rectangle, or a more specific type of rhombus. What do I have? Those are our squares. So squares have 4 right angles and 4 congruent sides. That's what makes them so special. So my kid will be like looking through like the Sesame Street finding the shape book or whatever, my 4-year-old, and they'll say, find all the rectangles in the room or whatever. And she'll only find the oblong rectangles, the ones that aren't squares. And I'll go, no, no, no. Those are rectangles too. No, mommy, those are squares. Yeah, but squares are also rectangles. And I'm already confusing them. Anyways, must love this. Anyway.
Wait, do they like count the squares or the?
So I make them count them.
Do they get
The book doesn't intend for you to count the squares when they say point to all the rectangles, but I
You should write a book.
Yeah. Yeah, I should write a book. Rhombus and squares are rectangles, right from the get-go. Why not? There's something else that's going to come up in your journal, and it's called a kite. And if you visually think of a kite, you kind of know what it looks like. But I think the thing, and I might try to change the Venn diagram before I do it again another time, but if you want to jot to the side somewhere, a kite, I'm trying to think where we would put it. But the thing about a kite is the adjacent sides are congruent, and then the other adjacent sides are congruent. And I think there might be something about the diagonals too. I'll have to look it up before we need it. I think it's in tomorrow's journal work. But so a kite, we'll have to get a little more detail on what specifically is a kite. So that's it for today's notes.